Forgive the shaking at the beginning of all of these. I'm using like a fancy tripod thing. It's kind of fun. Okay, so if you remember way back to when we started doing those little quizzes, we talked about Pythagorean theorem for pre-cal being x squared plus y squared equals r squared. And remember, that came from that x, y, r triangle, right? So that's that right triangle where we say a squared plus b squared is c squared. Now we say x squared plus y squared equals r squared. Well, because of that, we can do so much with this. So remember, sine is y over r, and r is 1 in our unit circle. So that's where we got sine is y. Cosine is x over r, where x is 1. So you know cosine, looks kind of like cosecant, sorry. Cosine is x, so that's where we built those things. So now thinking in identities, thinking how this works, if we know x is cosine and y is sine, now in our Pythagorean theorem, take x, replace it with cosine. Take y, replace it with sine. And r, we know, is 1 in the unit circle. So take x cosine and replace it. Take y sine and replace it. Take 1 for your r and replace it. And then we have derived an entirely new identity. So we know cosine squared plus sine squared of theta equals 1. And really, if you think about it, think back to that unit circle. If this is cosine, our x movement around that unit circle, right? Okay, that was terrible drawing, I apologize. If you move around the unit circle, this is the same thing, right? X squared plus y squared, and we remember that that x movement in that x direction was cosine, the y movement was sine, so that's just giving you your values of the ends of those triangle, the legs of that triangle, to get your y squared, which we know is 1 squared. So cosine squared plus sine squared is equal to 1. So this is a huge identity. Write it down 100 times so you remember it. Whatever you need to do to memorize that, that is a key one. Even if you have to derive it every time from that Pythagorean theorem for pre-cal, do what you need to memorize that, because this is critical. Okay, so the way it's typically written is sine squared plus cosine squared, just because for whatever reason we always think of sine first. So this is the typical way of writing that, but it does not matter which way you write it, right? Addition is commutative, doesn't matter which order you do that in. Okay, these we're not going to worry about proving at this point, but I want you to put these to memory as well, that 1 plus tangent squared is secant squared, 1 plus cotangent squared is cosecant squared of theta. Okay, so we'll prove them later. As I noted here, we'll have the joy and pleasure of doing that, but for right now, we're just going to leave it as it is, okay? Okay, so one other thing you need to think about, when you see these squared pieces, when we begin to like work out the identity problems, you'll start to see like cosine squared. Well, no, cosine squared is involved in this identity. So just using basic algebra, we could subtract sine squared from both sides, and end up with cosine squared of theta is equal to 1 minus sine squared theta. So if there's somewhere where you see cosine squared of theta, but it'd be more convenient to be dealing in terms of sine, we'll replace it with this. So you can start to see kind of how we're going to work out these problems and what it's going to look like. So I know there's a lot of information up front, but if you need to come back and watch these videos once we've started working problems, do that. Do what you need to do, or just refer back to your notes here. Okay, so then same is true here. If 1 plus tangent squared is secant squared, you can rearrange that by just subtracting that 1. So if you're given a tangent squared, you could replace that with this secant squared minus 1. Same with the 1 plus cotangent. Any way you need to rearrange this, do it, right? So this could also be cosecant squared minus 1 is equal to cotangent squared. There are just so many different things that you could do in just basic rearranging, depending on what you have and what you need to replace. All right, all ready to try some problems?